Hello student, welcome back. Today our topic is hydrates of p block element. First of all, what are hydrates? Hydrates are the compound of hydrogen with other element. These are the binary compounds. Now we know that p block elements we are having group 15 elements, group 16 and group 17. Group 15 element includes nitrogen, phosphorus, arsenic, antimony and bismuth. In the same way, group 16 element includes oxygen, sulfur, selenium, tellurium and polonium. In the same way, group 17 elements are fluorine, chlorine, bromine, iodine and astadine. Now, we are going to write the hydride of these elements. So, group 15 elements has valency 3. That's why it will have 3 hydrogen in their hydride. So, the formula will become NH3. In the same way, we are having here PH3. In the same way, ASH3, then SBH3, then BiH3. In case of group 16 element, since their valency is 2, so 2 hydrogen will be there in their hydride. So the formula will become H2O, H2S, H2Se, H2Te and H2PO. In the same way, elements of group 17 has valency is equal to 1. That's why they will have 1 hydrogen in their hydride. So the formula will become HF, then HCl, then HBr, then HI and then HAT. Now, what are the different properties of hydride? First property is reducing property, then basicity, then bond angle, then thermal stability, then melting point and boiling point. Guys, you have to remember directly that when we move from top to bottom, that is from NH3 to BiH3 in case of group 15, then reducing property generally increases, while basicity decreases, bond angle also decreases, thermal stability also decreases, but melting point and boiling point increases. This property you have to remember, guys, that only reducing properties and melting point boiling point increases, while basicity, bond angle and thermal stability is always decreases. So in the examination, questions are asked like this: arrange the following hydrides according to their increasing thermal stability, increasing bond angle, decreasing bond angle, increasing basic character, decreasing reducing property, like this. So just like we are having here question, arrange the following according to their first increasing thermal stability. Now we have seen from top to bottom thermal stability decreases, that is hydrides of upper element are always more stable as compared to hydrides of lower element or bottom element. Hence we can say that NH3 is thermally more stable as compared to PH3, as compared to ASH3, as compared to SBH3, then BiH3. That is bismuthane is the what? Thermally least stable, while ammonia is the thermally more stable. Next is arrange the following according to increasing reducing power. Just we have seen from top to bottom reducing power increases, means hydrides of bottom elements are good reducer as compared to hydrides of upper element. So we can say that HI is strong reducing agent as compared to HBr, as compared to HCl, as compared to HF. In fact, HF is not a reducing agent. Next question is arrange the following according to their increasing bond angle. Just we have seen that top to bottom bond angle decreases, means bond angle of the hydrides of upper element is always greater as compared to the hydrides of bottom element. Hence we can say that H2O has greater bond angle as compared to H2S, as compared to H2Se, as compared to H2Te, and finally we are having here H2PO. Now one question is homework for you. You have to arrange the group 17 hydride according to their increasing melting point in a comment box. Remember guys, from top to bottom acidic character always increases. It means that hydrides of bottom element are always more acidic as compared to hydrides of top element. So if we are going to compare the acidic characters of the hydrides of group 17 element, then we can say that HI should be more acidic as compared to HBr, as compared to HCl, as compared to HF. Same is true in case of hydrides of chalcogens, that is group 16 element, that is H2PO should be more acidic as compared to H2T, as compared to H2S, as compared to H2O. Now one more thing we are going to see in this lecture, that is oxidizing power and bond dissociation enthalpy of halogen. Guys, remember the question may be asked, arrange the following molecules according to their increasing oxidizing power, decreasing oxidizing power, increasing bond dissociation enthalpy. decreasing bond dissociation enthalpy. Then for halogens, we are having here fluorine, chlorine, bromine, iodine. So remember that oxidizing power of fluorine is always greater as compared to chlorine, as compared to bromine, as compared to iodine. While in case of bond dissociation enthalpy, you have to remember that bond dissociation enthalpy of chlorine is greater than bromine, greater than fluorine, greater than iodine. What is the expected trend? It should be expect that fluorine should have a greater bond dissociation enthalpy, but because of the shorter bond in between two fluorine atoms, the lone pair repulsion is very much high, and that creates the what? Decrease in bond dissociation enthalpy. So instead of fluorine at the first place, it appears at the third place in the what? Decreasing order of the bond dissociation enthalpy series. Thank you so much guys. Have a nice time. Take care.